First off, data bus control. What are we doing? We're seeing what happens or how we can take tri-state devices and control the direction of data, because these two go hand in hand here. Very basic operation of what goes on in a data bus. Okay, this is very, very, very basic. So we have our two control signals called chip select and read not write. We'll define this stuff again in a minute. I have an inverter that ensures complementary inputs if chip select is a logic high. The outputs on my AND gates are tied to the enable inputs of the tri-state device. I have two. One is for write operation. One's used for read operation. And I have peripheral land out here to communicate with via the CPU or vice versa. Because sometimes the peripheral device needs to be moved or keyboard needs to be typed on, whatever. CPU's got to process that. Signals are sent to and fro. So this information can be decoded and executed, things of that nature. Who's the boss?
CPU.
CPU is the boss. CPU is responsible for what? What's the CPU responsible for in this case? Yes! I got a lot of mumbling. Mr. Brown, CPU, what's this responsible for?
Control for, or it controls all the operations.
All of them?
Well, overall.
Overall, operations, like what operations? Be specific.
Like the operations of...
Or function. You can even just call it functions if you want.
It decides, because, yeah, the decoder sends up the CSAO, so doesn't it decide what reads and writes?
Yeah, overall operations. So, first off, yeah, we got two operations. It's either writing or reading. So, overall operations are oversees the read and write. And I'm going to put read and write. Yeah, so you're good. You're good, Brian. Read and write. There's something else. So it oversees the read and write operations. That's one. What else? Anything else?
Determines which device places data on and off the...
Okay. Determines which device. Since some of you all shitted the quiz, do we know what device means now? It's talking about the peripheral devices or the input-output devices. It's all the same stuff, the mouse, the keyboard, the monitor, that kind of thing. Device, what? Places on or takes data off the bus. Yeah. We all have these definitions, don't we?
Yes, sir.
Okay. So what's this magic bus that everything's riding on? In this case, I like it. Bidirectional pathway is awesome. AKA, quiet Cameron. AKA what? What do we call it? The data bus. Gee, the lesson's called data bus control. Holy cow. That's the magic bus, isn't it? Yeah. Whoa, the magic bus. Data bus. Look at the arrows. It's doing what? Both ways, bidirectional. Because information needs to be sent to and fro. Or writing or reading, CPU. If we're writing, what are we doing? What's the CPU doing for a write operation? Placing what? Data on the bus. And all in all, it's communicating with the peripheral devices. That's what's happening. What about a read operation? What's the CPU doing? It's taking the data off. Because now the peripheral device is like talking to the CPU. Hey, move me! These control signals, what are they called? What are they called? Hello?
Read and
Chip select, read not write. What's a key word there? Selects. This signal comes from where?
The decoder.
Comes from the decoder, and it's sent out. As long as that signal remains low, what's going on? Nothing. Once one of these devices requires communication or to exchange information with or data or whatever, here comes a logic high. That's that logic high. When I put H there, it's coming from a device. But the thing is, though, hey, is it a read or write operation? It depends on what this signal has, or this signal name has on this read not write. So it really depends on if the peripherals communicate with the CPU or the CPUs communicate with the peripheral device, depending on what this is. Make sense? Because that's the direction piece, isn't it? Well, there is.
No, sir.
It is. Yes, it is. You're crazy. So therefore, what's the definition of read not write? For a read not write signal, what's the big key word here? Rhymes with direction. It rhymes with direction! Kim, what is it? I can't hear you.
Direction.
Let me hear your war cry. Direction! Placed on or taken off. We already identified that. Placing data on and taken off. What has to do with this? Depends on if this signal's a what? High or low. Yeah. Data bus itself, it's what? Bidirectional, two ways. And what about it besides that? You already said it earlier. Nothing. Come on, you had a sexy definition for it.
Well, it says it's a bidirectional.
Yeah, I like it. Because isn't that what a bus is? Isn't it a pathway for data and bits of information? Yes, it is. Bidirectional pathway. Between what?
CPU.
Between the CPU and I/O devices or peripheral devices. That's what it is. So you think we're about defined out here? Okay. Look. Don't let these definitions kick your arse. Because I'm trying to help you by pointing out key words. Chip select, gee, it's got the word select in it. Come on now. Selection device. What device? Peripheral device. And communicate. I need to talk to the CPU. Chip select signal comes back high. I need to communicate. Okay. Read not write controls the direction of the data. Hey, is it a read or a write operation? These two control signals are required for anything to happen. Because if this one's a low, nothing going to happen, Salmon. Okay. And I hope we can remember CPU's the boss and controls the overall operation. What? Read and write. With respect to, you got to respect the CPU. Respect it.